Okay, guys, I hope you're doing great. Thank you so much for watching this video. And today I'm going to talk about optimization. So remember, I'm trying to simplify the idea of optimization just to let you get prepared for your final exam if you're a DP2 student. So what is optimization? Let's summarize and simplify it like this. When we talk about optimization, we are trying to find the highest or the lowest value of a function, often subject to constraints. What does it mean? I'm going to go and explain it on a graph. Okay, let's suppose that the graph of a function is given to you. This is the graph of a function, given function. Okay, this is the graph. Okay, in optimization question, I'm interested to find this maximum point. In this case, it's a maximum point, but you can also talk about a minimum point. I'm going to find the maximum point. If you have the main function, if you have the graph of the function, you simply put the main function into the calculator and you find this maximum point. I suppose you know how to do it. Analyze graph, analyze graph, and you're going to go for max, okay, on your GDC or graphical display calculator. Okay, that's about the graph. Now, let's talk about the equation. If you have the equation, not the graph, okay, you're going to go and find the derivative of that function. Okay, so this is the reason we learn about optimization after derivative, okay, because we want to be able to find the derivative. And once you know the derivative, you put it equals to 0. All the solutions for this equation, they give you the possible maximum or minimum points. Okay, remember, in your course, this is the way to do the things, but it's not the best and the most precise definition on how to find the maximum or minimum point. In your course, it's more than enough. That's it. Okay, because we can have some points that the derivative at that point is not 0, but it's still a maximum point or a minimum point. One more time, it's not the case of your course, so don't worry about that. Okay, great. Okay, let's have a quick recap on how to find the derivative of a polynomial function. Remember, if you have a function in this form, the power rule, the derivative is a times n x to the power of n minus 1. A couple of examples. 3x to the power of 4, its derivative is 3 times 4 times x to the power of 4 minus 1, which is 3. Okay, so this is a prior knowledge, and this is also a prior knowledge. Now, we know a little about optimization. Now I'm going to give you a general structure of optimization questions. Okay, keep it in mind. This algorithm, this pattern, I think it really helps you to solve this kind of questions easier with more confidence. Okay, so normally you have a constraint. What does it mean? I'm going to tell you with an example. Okay, based on that constraint, a function is given to you. Okay, but the problem is that the function is based on 2 or 3 variables. Okay, so for example, constraint is that the sum of two numbers, addition of two numbers, x plus y equals to 10. Can you tell me what is the maximum value of their multiplication? Okay, so what is the maximum value of their multiplication? Let's define a function. I'm calling it with m. What is the maximum value of the multiplication of x and y, which is xy? What is the maximum value of this function? Okay, do you agree with me here? I have two variables, x and y, but we always want to have only one variable, one input. Here we have two variables. So we're going to use this constraint. To get rid of one of these variables. And I'm going to tell you how. We mix them together and we make a function with only one variable, based on only one variable, based on only x. Okay, and then we're going to go and graph it, or we're going to find the derivative of that, put it equals to 0 and find the minimum or maximum point. Let's do it together. Okay, so you know that your constraint is the sum of these two numbers equals to 10. So do you agree with me? I can say y equals to 10 minus x if I put x to the other side. Yes or no? I'm not inventing anything. I'm just saying, can I put x to the other side? Maybe yes. So y equals to 10 minus x. Okay. So do you agree with me now? The function of multiplication, I can write it like x times 10 minus x. And do you agree with me here? Now I have only one variable, one input. So my function is only based on one input, not two different inputs or three different inputs. Okay. Look at this function. You can either go and graph it with your calculator, or you can go and find the derivative, okay, and put it equals to 0. Both methods help you to find the value of x in which you can have the maximum possible value for this function. Let's go and see. I'm going to do both methods for you, okay? First, let's go for graphing. I'm going to go and graph this function x minus x times 10 minus x. 10 minus x. Let's graph this function. Okay, I need to put the multiplication. Okay, so look at my function. If I go up and up on my calculator, can I go and find this maximum point? Maybe yes. Menu, analyze graph, maximum. I'm finding this maximum here. What does this 5 and 25? What does it mean? Okay, this point here, 5 and 25. Remember, my maximum point in this case is 5 and 25. It means that if x equals to 5, you're going to have the maximum possible value for the multiplication function, multiplication of these two numbers, which is 25. So let's recap it verbally one more time. If the sum of two numbers equals to 25, if the sum of two numbers, two natural numbers, equals to 25, the maximum possible value for their multiplication happens when one number is 5. Obviously, the other number is also 5. 5 times 5 gives you 25. It's impossible to have a number greater than 25 in this case. Okay, so for example, if you choose 6 and 4, 6 times 4 is 24. If you choose 7 and 3, 7 times 3 is 21. Okay, the maximum possible value for the multiplication of x times y equals to 25. When does it happen? When one number is 5 and the other number is also 5. Okay, but can I also solve this with derivative? Why not? What is the derivative of this function? M equals to 10x minus x to the power of 2. Okay, so how can I find the derivative of this function? M prime of x equals to 10 minus 2x. Remember, in this question, the aim of this question is not to practice power rules. Maybe I can record another video and we can practice how to find the derivative of these kind of functions. It sounds easy to me. I think you can also practice and do it on your own. 10 minus 2x. So can I put 10 minus 2x equals to 0? Yes, if you solve it, if you want with numerical solve, x equals to literally 5. It's exactly the same value. What does it mean? When x is 5, you're going to have the maximum possible value for this function. What is that value? Put 5 into the main function, not into the derivative. 5 times 10 minus 5 gives you 25. Okay, so this is the general idea of optimization. It's very important, so I'm going to recap it one more time. Optimization is about finding maximum point or minimum point of a main function, f of x, okay? Normally, you have a constraint. Normally, you have a condition to consider, okay? Then they are asking you about a function. In this case, it's the multiplication of these two numbers. Based on the constraint, you have to isolate for one of the variables. So you write one variable based on the other one. You make your function of based on two variables into a function based on only one variable. You can see it here. You can go and find the maximum point or the minimum point in two different ways. It depends upon the question also. With graphing or with derivative. Okay, graphing, we did it once. With derivative, you have to put it equals to 0. Now, let's go and solve one slightly harder question. Angelina Jolie is designing an open-top rectangular storage tray for an art project. She starts with a rectangular piece of cardboard measuring 4 centimeter times or per 24 centimeter. Okay, you have the graph here. Okay, to form the tray, Angelina cuts squares of side length x centimeter from each corner. Okay, so basically we're talking about these sections here. After removing the corner squares, Angelina folds up the sides to form the open top tray. I think it's understandable for you. Basically, we are we are making, in this case, Angelina Jolie is making an open top box. Okay, so here is open. Okay, now write down in terms of x expressions for the length, width, and height of the tray. Okay, so what is your length? Length, this measure here of the tray is 40 minus, this is x, this is also x, so it's going to be minus 2x. What about the width? It's going to be 24 minus 2x. And what about the height? Remember, this is going to be your height, so your height is x. So let's recap it. Height is x. Width is 24 minus 2x. And length is 40 minus 2x. Okay, now state whether x can equal state whether x can not be equal 12. Give a reason for your answer. Okay, I think it's cannot. Let's see. So x, do you agree with me that the length, height, and width, they have to be positive numbers? You cannot tell me that the height, length, and width of any shape is negative. Okay, so what does it mean? X, it has to be positive. 24 minus 2x, it also has to be positive. And 40 minus 2x, it also has to be positive. X positive is clear. 24 minus 2x, it means, if you isolate for x, it means x, it has to be less than 12. And 40 minus 2x, it means x, it has to be less than 20. Okay, so what does this mean? This means that x, it has to be between 0 and 12. Okay, because the common answer, it has to include all the conditions. Okay, x, it has to be positive, but it also has to be less than 12 and less than 20. So 18 is not an acceptable answer because 18 is not less than 12. Okay, so x cannot be 12 because if x equals to 12, the length of the width is going to be 0. Okay, it has to be less than 12 for part B, I. So it cannot. Okay, whether state whether write down the interval for the possible values of x. Okay, we did it here actually. Okay, that's great. Now show that the volume of the tray is given by v equals to 4x to the power of 3 minus 128x to the power of 2 plus 960x. Okay, show that the equation of the volume is this. Okay, so what is the equation for the volume? Well, equation of the volume is length, you have it in your formula booklet, times width times height. Okay, so your length is 40 minus 2x. Your width is 24 minus 2x. And your height is x. Okay, you need to multiply all of these terms by each other. So 40 times 24 gives you 960. Okay, I have it here, 960, yes. 40 times minus 2x is minus 80x minus, so you have to multiply everything by everything, okay? Forget about x for a second. We're going to multiply by x at the end, okay? Multiply by x. Minus 2x times 24 is minus 48 x, and minus 2x times minus 2x is 4x to the power of 2. Remember, I have to multiply everything by an x, so the final answer is 4x to the power of 3 minus 128x to the power of 2 plus 960x. Okay, so this is the formula for the volume, which is exactly what we have on the top. Okay, remember here, or better to say here, you have a function based on three variables: length, width, and height. V equals to length times width times height. Okay, so you have three inputs, three types of input, and you're going to get rid of two of them. Thanks to this step here, thanks to the fact that I know that length equals to 40 minus 2x and width equals to 24 minus 2x, we now have an equation for the volume based on only one variable. Now, there are different ways to find the maximum possible value of the trail. Question is making our job here very easy. It is asking us go and find the derivative. Okay, so what is the derivative of this function? 4x to the power of 3 minus 128. Let me see, minus 128x to the power of 2 plus 960x. This is the function for the volume. How can I find the derivative? Again, I'm skipping this part to explain because I think we need another video, particularly about how to find the derivative of given functions, polynomial function. Okay, so this is the function of the derivative. You put it equals to 0, and those x values are going to give you the possible value of the maximum or minimum point. Using your answer from part D, find the value of x that maximizes the volume of the tray. So what was the equation? 12x to the power of 2 derivative equals to 12x to the power of 2 minus 256x plus 960. Okay, I put it equals to 0. Now I need to solve this. Let's go and solve this with our calculator. Okay, you're gonna make a new tab, add calculator. We're gonna use polyroots. I hope you have used this function before. It's a way to find the roots of polynomial expressions or equations. Okay, 12x to the power of 2. Remember, what is, answer this question, what is wrong with using numerical solve here? What is your answer? Maybe you're right. The problem with numerical solve is that it only gives you one answer. Okay, so you have to learn how to solve this answer, the solution of this answer, also with polyroots. I don't put any equal. Look at the form of polyroots. Okay, 12x to the power of 2 minus 256x and plus 960 without any equal. It's not about the equation, just put the expression. If you press enter, it gives you the zeros. Let me put control enter. So these two answers, 4.85 and 16.48, they make my function, they are the maximum or minimum point of my function. Okay, however, 16 is definitely not acceptable because it's not within the range. You remember that we said x, it has to be between 0 and 12. So 16 is not acceptable. 4.85 is the right answer. So x equals to 4.85. Okay, so for x equals to 4.85, you're going to have the maximum possible value of this box. Okay, if I ask you what is the maximum value, calculate the maximum value, you're going to put this value into the main function. It's a very common mistake. You have to put this into the main function, not the derivative, because if you put it into the derivative, it gives you 0. So what is the main function? 4x to the power of 3 V max equals to 4x to the power of 3 minus 120 x to the power of 2 plus 960x. Okay, do I have to do it for you? Maybe yes. So let me do it here to find the maximum value. So what was that? 4x to the power of 3. So 4x to the power of 3. 128 x to the power of 2, 960x. Let me check. 4x to the power of 3 minus 120x to the power of 2, x. Okay, instead of x, I have to put 4.85. 4.85. 4.85. 4.85. Press enter. 2101. 2101. If you want to give it in three significant figures, 2100 is the maximum volume you can have within this condition. Okay, considering this condition that it has to be 24 times 40, the maximum possible value of your box is going to be 2100 of unit to the power of 3. Okay, and it happens when x is 4.85. I'm going to do it also graphically to practice it. Yes, it is actually what question is asking you. Can you go and graph it when v is between 0 and, this is not the right thing, okay? When it's v is between 0 and, let's say, 2500, okay? So let's go and graph your main function, okay? I'm going to go and graph v based on x. How to do it? It's a good question to practice graphing, okay? This is the function. No, I need to do it one more time. So add graph. What is my function? 4x to the power of 3 minus 128x to the power of 2 plus 960x. Okay, this is my function. When I press enter, I don't see the majority part of my function. What do I have to do? I'm going to come on menu, and it's a very common thing or problem in your, it's not a problem, it's something that can happen, okay, in your exam. So you're going to go on window, zoom, window setting. For y max, maybe we can put 1500. Let's see. Okay, we still need to change it one more time. Window setting. For y maximum, you're going to put maybe 2200. Okay, now you have the whole function here. You're going to go and choose analyze graph, maximum point. Here we go. Isn't it exactly what we found also algebraically? 4.85. So when x is 4.85, you're going to have the maximum possible value for the volume, which is 2100. Okay. Now, one more thing, just to make sure you get everything about this question. If you want to go and graph the derivative of this function, what is the derivative? You're going to go and do this menu, graph, function. Here, you're going to go and choose derivative of f2x. Okay, now you have the black is the function of the derivative. Look at this point. Let me go and find the intersection. Analyze graph, 0. Isn't it exactly 4.85? What does it mean? It means that derivative before that point is positive, so you're going up. Then it's 0 at 4.85. and then it's negative, so you're going down in the main function. So it's a maximum point. It's a maximum point. Okay. Now let me go and graph it. How can I graph it? My function has a form like this. The rest of this function we are not interested in. It's this point is 12, this point 4.85, and 2100, and this point is 0. That's it. Thank you. Thank you so much for watching this video. I hope it has been helpful for you to watch this video for how many minutes? I don't have the minute here, but I appreciate that. Thank you.